Just bringing you back for part two of the big bore conversion, as I referred to it in the previous video. I did have plans of showing you assembling it bit by bit, but I did do a video, but it just went way too long. And from the first video I've done, I don't need to drag you through another long video, and you can get a grasp of what I've done by just seeing the assembly now. But I'll just take you through a few things that I've sort of covered in the first one and just come back and sort of revisit those things, just to, as I say, cover what I sort of thought I was going to do and change some of the things I did change. I mentioned that I was going to use this mount here and bore it out to 40mm that I was thinking about, but I finished up just making a complete new shaft and reusing a part from the actual rotator itself, or position, or whatever you want to call it. Just one other thing while I got you. Probably more so, this information probably handy for guys who are going to buy one, more so than guys just generally watching the video. But I did mention in the first video this chuck was weighed about roughly about 5 kilos. It was just a bit of a guesstimate, but I finished up weighing it just to get an exact weight because I wasn't sure, and I finished up weighing 6 kilos, so it wasn't too bad for a guesstimate. But I think you'd be sort of going to get a lathe chuck weighing anywhere like that, and this is 8-inch diameter, so you can hold a fairly decent sized part. But I just sort of add that in just for info, as I say, for guys who are looking at buying one. And it does have an 80mm bore, and the depth from the base to the tips of it, or to the face of the actual jaws themselves, is around 70mm. So you can hold a reasonable part in there, so you can hold a 3-inch part in there, I suppose, if you needed to. But just taking you over to the front of it now, if I just get a bit of light on there, you won't be able to see much down the bore because I've painted the actual ID black just to stop from rusting and just to match the rest of the faceplate too. You can see a bit of light coming through the other end there. I'll take you down and show you what I've done down there in a moment. I finished up using the bearing mount from the original assembly. So in that previous video, I had this bearing was sitting in there when you would have seen it, and we was looking at that with the faceplate taken off, and we went around inside and had a look at the other side, had a bearing on each side, and I was working out what I was going to do there. So what I finished up being able to do was use that part and machine it up to match the actual shaft that I've made up. It's a bit of a shame. I would have liked to have shown you that shaft, but not a big deal. It's just 55mm diameter bar with an 18mm tail on it. So sort of a la the other version. So this portion here is 55 on the Odin, and this part's here 18mm, obviously, to match the drive. Just taking you up on top now. I will bring you on a bit of a run of it. I will run it to sort of show guys who are interested in the sort of speeds of it. You can sort of see that mount there. So that was actually mounted here directly into this sheet metal panel. So at the moment I've made up I suppose a bearing mount inside here. You can sort of see the socket head screw sort of hold that in place. So you got one 90mm by 55mm ID bearing, and another one back about here. I've added in a section here just to get a bit more length in the hollow bar, in the hollow tube, I should say. I suppose it is a hollow tube now because I've bored it out so far. As I say, 55 OD and 45 ID, and I've added an extra 65mm back here. So taking you around to the back now, just seeing where that light was sort of coming in, if I can get in there okay. So it was originally a bolt in here because I wanted a through tube for a purge line to go through to the other side. I finished up having to put a thread on the end of the shaft there, so you can just sort of see through the other side there. I've just drilled a 6.5mm hole through there. I couldn't get too carried away with the idea of the hole because I've got a keyway coming in on one side. Yeah, it's a bit of a shame I couldn't really show that, but as I say, it's just a pretty plain shaft. It's had a huge reduction on it, down from 55 down to 18mm, so it did look a bit funny. But the actual weight of it, I didn't actually weigh it, but I held this shaft, sort of like you can sort of compare weights in your hand, and this shaft, even with that spigot, this spigot mounted on the front of the other shaft, actually compare the two side by side, weighing them in each hand, this shaft still feels heavier than the new shaft, even though the new shaft's a larger size. The other thing I did do was fix up the slot in this part here where it had that sort of play in there. So I fixed that now to take out that play. as you're winding it down. It did drop down in that last video, so that, as I say, that nylon bush was damaged in shipment, so it wasn't a big deal just to spin up another bush. I haven't cut it down as yet, just leave it to see how it goes. I just want to try and get it back together so it's all in one piece. It's more so just to get it out the way, because when you've got things in pieces, you've got stuff everywhere and things seem to get lost or misplaced. So I just want to get it back in one piece. I haven't done the standoffs as yet. I will do those soon, but as I say, I just want to get it back together. So the chance of losing things is probably good if you leave things laying around for too long. And with a few jobs coming in now, I sort of have to get moving on it. It's taken a bit of my bench space that I need to get on and do some jobs. So the plan is just to cut it off probably here and move this mount down, and then I'll move these down further. As I say, I'll make these at a later time. One question, or I don't say question, but one of the comments that came up was the contact here, because when I was showing you that last video, it was pretty early days. I hadn't done anything as yet on this actual unit yet. I was just sort of showing you guys while I was in thought process of what I was going to do to get that bore size up, and just giving you a bit of a look over it at the same time. But I've cleaned this surface off here. I just cleaned it off with emery, just to get the paint, or this, not to say paint, it's actually a black coating to prolong the life of the plate. And you can sort of see some of the machine marks that are still in there, but that'll wear down over time anyway. As you start to use it, that copper block will start to wear down. So we just get a good contact between the copper block and the actual material itself, so it's not possibly arcing out through this coating, because coatings do get a bit fussy with electrical current passing through them. So that was something that I wanted to do, but I just sort of just point that out, just so that was covered in this video anyway, to sort of answer that question, I suppose, what I was going to do there. I suppose bringing you down to the actual control box now is one thing I wanted to show you. Just as I say, no, it's sort of last sort of guys that wanted to buy one, but sort of interesting to know as well anyway. I didn't show you much of it at that time in the last video, so just going through it quickly. The timing down the bottom, I just want to go through the speeds of it, because there's, as I say, there's a few guys that probably want to buy something like this and not sure, and this might help them out. The speed of the positioners for the actual surface plate or turntable to turn is a question mark that I noticed in a lot of forums, guys talking about different positioners and rotators that were available, and the price of being in that lower end market, I suppose, and that's where this is too, even though it's not a cheap unit, but still fits into that lower price version. And the problem was with a lot of them was they don't turn slow enough. So that was the thing. Also with TIG rather than MIG. MIG's not so much for a problem, you have a bit more speed than TIG, but you can get it running down pretty much almost to a snail crawl. So what I'll do is I'll just get it switched on. Just one thing for you guys who are going to buy one, they don't run pretty much down on zero. So if you turn it down to zero, it pretty much is off. So that's on its base there now. So I'll just get you back and sort of press the button, and you can sort of, pretty much nothing happens. So you're going to move it up to about that, probably just past the 9 o'clock mark, I suppose you could say. So on the side here, you can probably just see that little mark. You can just see how slow that's going to turn now. It sounds like it's stalling, but it actually is moving. It's probably hard to tell. I think I've seen grass grow faster than this is turning, and probably just suit if you watch the slots turning. So that is very slow. I don't know what that'd be turning. I think it'd be turning like 1 RPM every. I don't think it'd be RPMs. I think it'd be RPM per hour, I think, or RPH. I think more so than anything else how slow it's turning. So there's no drama about how slow it turns. You can sort of see the bolt heads lining up in the center here. They're starting to sort of come into line. They start to move off center. So, but if you hear that sound, it sounds like the motor's stalling. So that definitely gives you an indication of how slow it is. So, so that's actually definitely slow enough. Just turn up to its full speed now to give you an idea. As I say, this is probably more for your MIG than TIG. So that's pretty much at top speed now. I think the high speed's never been a problem with these positioners. It's more so that lower range. It's always a bit of a problem with them. And as I've said, you can set the timer on there. I'll just quickly show you how that works. You've got to take into account that this is measured in seconds, not per rotation, so you'll have to muck around with these little dip switches on here. You can flip these little dip switches, I think they are down the bottom here, I think. I know you just little buttons. I think you just press these little buttons, as I say. There's nothing much in the instructions, unfortunately, what you do with these, but when you muck around with things, you usually find you can work them out quicker than actually looking at instructions. I find sometimes you read instructions, they're more confusing than what you already are. So sometimes you just muck around with things and you actually find out how they work. So I'll just turn that back to sort of its minimum position. You switch it over to auto and you use this reset button. So this is a little bit different to my Profax position I had previously. So the reset was just to reset the actual overload, but it's a bit of a different setup with this one. So you actually press the reset to actually start off the timer. So I just press that and you can see the timer counting. So it just counts up to 11.11 it seems to be. There seems to be a decimal point in there. And that's just that's just the table turning. So I'll turn it up to height. I'll turn it up to maybe halfway, what seems to be halfway. I'll just press the reset. You can sort of see the timer running on it. That's what I say, you have to muck around for a little bit to get the position where you want it to start and stop. Of course, you just do the math on it. You just do the diameter by how many seconds. It's a pretty easy calculation. Just get a calculator, you quickly work that out. So that's as far as it goes on that setting. As I say, you just muck around with those switches there and you can get the actual timing. So this is on full speed. It just goes over just over one full rotation. So as I say, it's in seconds. It's not nothing to do with rotation. So you just do the math and you'll soon get that sorted out. As you can see, it's probably just come a little bit past the start point. That'll probably do for this video. I can't really think much else to sort of show you. That's probably just more so just covered the assembly more than anything else. Just one other thing while I was thinking of it, I just sort of bring my earth lead in. I know it's, as I mentioned in the first video, it's probably tempting to do this, but as I say, that's totally up to you how you set up your positioner. But what I'll be doing is, as you can see, most of the earth leads have got these lugs on here which match up to what's on there, or close to it anyway. This is a 400 amp clamp, and you just, all I'll be doing is just to get it going, because I don't have a cable made up for it. You're just unbolting it off the earth clamp and just bolting it onto here, because obviously with any electrical you need good connection, and more so with welding, you don't want any points that haven't got good contact. So as I say, I'll leave it up to you whether you want to bolt it together or you want to take a chance and do it this way. It'll probably be fine like that, but I can't say I'd recommend it. As I say, I'll leave that one up to you guys, what you want to do there. That's pretty much covered everything that I can think of. If anything comes up or any questions that you want to know that I haven't maybe covered or weren't clear in this video, just get back to me in the comments. More than happy to answer anything. All right, I hope you guys enjoyed this video and look forward to seeing you back on the next one. Okay, bye for now.